1994 AB4. A particle moves along the x-axis so that at any time t is greater than 0, its velocity is given by v of t equals t ln of t minus t. At t equals 1, the position of the particle is x of 1 equals 0. Part A. Write an expression for the acceleration of the particle. The acceleration formula equals the velocity's derivative formula, which equals ln of t plus t times 1 over t minus 1, which equals the ln of t. For what values t is the particle moving right? To find where it's moving right, you set your velocity formula t ln of t minus t greater than 0 and take out t as a common factor and find that t has to be greater than e. Part C. What is the minimum velocity of the particle? To find your velocity, you set ln of t, your derivative of the velocity formula, equal to 0 and find that t equals 1. Therefore, your only 0 is at t equals 1 and you find where it's positive and negative. Your minimum velocity is at v of 1, which equals negative 1. Part D. Write an expression of position x of t of the particle. X of t equals the integral of t ln of t minus t dt. Therefore, you have 1/2 t squared ln of t minus 1/4 t squared minus 1/2 t squared plus c. To find your constant, you use x of 1 equals 6 and make 6 equal to 1/2 t squared ln of t minus 3/4 t squared plus c. You let your t equal 1. Therefore, 0 minus 3/4 plus c has to equal 6 and c equals 27/4. So your final position formula is 1/2 t squared ln of t minus 3/4 t squared plus 27/4. 1998 BC2. Let f be function given by f of x equals 2x e to the 2x. Part A. Find the limit as x approaches negative infinity and the limit as x approaches positive infinity of f of x. The limit as x approaches negative infinity of 2x e to the 2x equals 0, and the limit as x approaches positive infinity of 2x e to the 2x equals infinity or dne does not exist. Part B. Find the absolute value of f as a minimum. Justify. You take f's derivative, and that is 2e to the 2x plus 2x times 2 times e to the 2x, and you take out 2e to the 2x as a common factor and leave 1 plus 2x in parentheses and set that equal to 0. You find that x has to equal negative 1/2 for this to be true, and you find f of negative 1/2 and it equals negative 1 over e or negative 0.368. Therefore, negative 1 over e is your absolute minimum. You can justify in two ways. By saying f prime of x less than 0 means that all x is less than negative 1/2, and f prime of x greater than 0 means that all x's are greater than negative 1/2. Or you can justify with double I that shows the graph of the derivative of f of x and negative 1/2 as a critical. And it shows that x equals negative 1/2 is the only critical point. Therefore, it has to be the absolute minimum because your slope changes from negative to positive. Part C. Find the range of f. You find the range of f by using your critical points and finding where it goes to infinity. So your range of f is negative 1 over e in brackets, comma, infinity. Or you can say negative 0.368 in brackets, comma, infinity in decimal form. Part D. Consider the family functions given by y equals bx e to the bx, where b does not equal 0. Shows same value of absolute minimum of bx e to the bx equals all non-zero values of b. To find this, you take the derivative of y, which equals be to the bx plus b squared xe bx, which then equals be to the bx, parentheses, 1 plus bx, close parentheses, and set that equal to 0. You find that x has to equal negative 1 over b, and you plug this in to your equation and find that at x equals negative 1 over b, y equals negative 1 over e. So therefore, y has the absolute minimum value for negative 1 over e of all non-zero b's.